And our journey continues at page 7, where we have the given statement AB is perpendicular to CD. Jot that down as a given. So let's see what that means. AB perpendicular to CD. Oh, hello, Mr. Typo. I don't know if this is like this on your handout, but if it is, that's a typo bonus opportunity for someone. All right. So if they're perpendicular, then I know that I have two congruent 90-degree angles. All right. So I'm actually going to jump to, I'm very impatient here. I'm going to jump to a conclusion right away. All right. So I'm not even going to consider my second given sentence there. All right. So I'm going to say that angle ADC is congruent to angle BDC. And that's because perpendicular lines form, got to throw the word congruent in there, congruent 90-degree angles. All right, now form, jeez Louise, form congruent 90-degree angles. Now, you might say, well, that seems extraneous. Here's the deal. My statement wasn't that the two angles are 90 degrees. My statements were that the two angles were congruent. So my reason needs to justify congruency. So the perpendicular lines form 90-degree angles, true. But those 90-degree angles are congruent to one another, which allows me to make the statement that those two angles, those two given angles, are in fact congruent. Right? Seems like really a weird thing to add on, but it's a necessary thing to add on unless you want to add in an additional step. Because you could say angle ADC and BDC are 90-degree angles. Perpendicular lines form 90-degree angles. And then you could say ADC is congruent to BDC. All 90-degree angles are congruent. Instead of doing that, we can combine it in one step. All right. So step 3 this time is going to be that CD bisects angle ACB. That's a given. So CD, ACB. Okay, so we've worked with that before. ACB is right up at the vertex angle. So we're looking at an angle bisector. So we know that ACD is going to be congruent to BCD. And this would be definition of angle bisector. All right. Now the one other piece of information is a pretty common piece to include in a proof, and that would be the reflexive side. CD is congruent to CD, reflexive property. And so now what I have, and I'll just kind of zoom in for it. Oh, I hate when I do that. I do that in every video now. Get my D back in there. I have an angle, another angle, and a side sandwiched in between the two. You can't get one from one angle to another without going through the side first. All right, which means that we're looking at the ASA axiom. So my two triangles would be congruent by that relationship. So angle DAC, congruent, angle triangle, to triangle DBC. I always want to make the naming of the triangles correspond to the prove statement that they asked initially, because otherwise I haven't proved exactly what they said. Right? It's kind of like if somebody said, "Is Theodore in class today?" and the reply was, "Yes, Ted's in class today." Yeah, you're probably talking about the same person, but we're not 100% sure. Right? That's an iffy analogy, but hopefully it gets the point across. All right. It also depends on you knowing that Ted is a nickname for Theodore. All right, so it's actually one of a few. So, as I found out throughout the course of my life, so A and E are congruent. ACF. I'm gonna, you know what? I'm gonna do them one at a time. I was gonna go in a different direction, but I'm gonna do them one at a time. A is congruent to angle E. That's a given. I might list them all in the same givens, but I want to be a little bit more careful with this. BD and FC. I'm skipping that trickier one, which talks about exterior angles, ACF. So let me bring that in. ACF is this guy right here. And EDB. All right, so those two angles are congruent to one another. So that's all useful information. It's actually going to get us very close to what we need. All right, let me get my given in there, the rest of the given anyway. Angle ACF congruent to angle EDB, and then BD congruent to FC. All right, so the first thing I would want to somehow come up with is the idea that these two angles, I'll give them 3 arcs, are congruent to one another. All right, so I'm going to make a statement, and it's going to be a very intermediary or intermediate statement. I'm going to make, and it's a combo statement, 2 statements in one. I'm going to say that angle BDE, and actually let me give a little bit more room there. I might have to scroll a little bit. So it's actually the measure of angle BDE plus the measure of angle BDA is 180 degrees. And ACF, let me start off with the F. FCA and FCE. All right. So there's a couple of ways that we could justify this or these statements. One would be that we're just simply looking at supplementary relationships. All right. Supplementary angles add to 180 degrees. All right, now here what we're going to do is actually work off a piece of information that we already have. All right, and so it's going to be a little on the strange side, but it's something that it's kind of a necessary evil. All right, and naming your angles kind of it sort of makes it important that you understand how angles are named, because you do need to recognize that when I'm talking about angle FCA, I'm referring to the same angle as ACF, and when I'm talking about angle, was it EDB, I'm referring to the same angle as BDE. All right. So I'm going to just do a little side work here. And the side work actually is contained within the proof, which is kind of a weird thing, but that's the way it goes. All right. So what I'm going to do is write as a separate step that the measure of angle BDA is equal to 180 degrees minus the measure of angle BDE. And I'm going to do the same thing where I say the measure of angle FCE is equal to 180 minus the measure of angle FCA. All right, and that's the subtraction property. So that's just basic algebra. All right. So we're just subtracting from one side of an equation to another. The reason why that's useful is because now I can make a substitution. All right. I can replace, let me just change the colors here. In my next step, I can substitute out, because I know that FCA, and I'm going to restate a given, just so I can make it clear. So recall angle ACF is congruent to angle EDB. That's a given, all right? This next step is going to be a little bit weird because it's going to seem completely unnecessary, and oftentimes it really is. But I'm going to make the statement that the measure of angle ACF is equal to the measure of angle EDB. And that's because congruent angles, I'm going to use mostly symbols here, if I can properly create a symbol. That's an angle symbol. Congruent angles have equal measures. All right, so congruent angles have equal measures. And then I'm just going to note that this is the same as, all right, so one little tilde is talking about equivalence, that this is equivalent to the measure of angle, because I wanted to have it in the same notation, angle FCA being equal to the measure of angle BDE, sorry. Now, I could have saved myself this step if I had named the angle properly, and that's a little bit on me. And who am I kidding? It's completely on me. But, you know, the damage had already been done at that point, so I'm just kind of going with it. So what I'm looking at now, step 5 in the process, is because these two things are equivalent to one another, I can make the substitution in one or the other. It doesn't make a difference, all right? Because they're going to end up being equivalent. So I can now state, for example, that, and I'll choose this one, that the measure of angle FCE is equal to 180 minus the measure of angle BDE. Move this over a smidge. And that's substitution. Substitution. All right, because all I did, that's the weird part, but it works. I'm just replacing the FCA with what I know it's equivalent to, It's equivalent to the BDE. All right. So now BDA and FCE are equivalent to the same things. My little bottom of the E didn't show up there. All right. So I'm going to do another recall. And this is just to refresh memory. I honestly wouldn't write this in a proof. It's just for your benefit that I'm writing this. I'm writing recall measure of angle BDA is equal to 180 minus the measure of angle BDE. We stated that earlier. So now I can state that in step 6, measure of angle FCE would be congruent to the measure of angle BDA, also by substitution. And that's happening because I know that angle FCE is equivalent to this. Angle BDA is equivalent to this. That is not a highlighter. It's equivalent to this. And those two things happen to be the same. So if two things are equivalent to one another, they must be equal to each other. All right. If A is equal to B and B is equal to C, then A is equal to C. All right. So then that would follow logically, and that's not a marker, okay. So it would follow logically that angle FCE is congruent, glitchy pen now, angle BDA where before I said congruent angles have equal measures, angles with equal measures are congruent. All right, now at long last, I mean this is the longest proof we've done so far. Only because of this additional work that we've had to include, really. If we didn't have to state all this stuff, and that's what happens a lot of the time, you know, proofs end up being bogged down in the fact that we have to state every little tiny detail. Because if you were to say, well, they're supplements of one another. If they're supplements of one another, that means they add up to 180. If they add up to 180 and I know one of them, I know the other one. And if I know that two angles are equal, then their supplements have to be equal. And if I know that they're equal, they must be congruent. If they're congruent, then that's going to allow me to prove that the triangle is congruent, in this case, by angle, angle, side. But all of that needs to be justified, right? And that's a lot. But we're there because we have two sets of corresponding congruent angles, and we have a side that's not in between them, right? So ABD and EFC are congruent. So triangle ABD and EFC are congruent by the AAS axiom. All right. So I did mention that I could have saved myself a step or two had I named the angles in step 2 a little bit more consistently with the way they were named initially. So instead of calling the angles BDE and FCA, I could have called them EDB and ACF, but I didn't, and so, you know, I paid a little bit of a price later on. But in any event, it does kind of show that it allows you to recover even if you do go down a little bit of a different pathway, because as long as your methodology is grounded in logic, there is no wrong pathway. It's just sometimes it's a little bit extraneous. All right, so AAS axiom, and there it is.